We're given vector A in component form and asked to find a unit vector in the direction of vector A. To find the unit vector in the direction of a vector v, we first find the magnitude of vector v, and then the unit vector in the direction of vector v is equal to vector v divided by the magnitude of the vector, which is equivalent to multiplying each component of the vector by 1 over the magnitude. Before we do this though, let's take a look at the graph of vector A in space as well as the unit vector in the direction of vector A. So here's a graph of vector A in space, the blue vector, and the red vector is a unit vector in the same direction as vector A. So we're looking for the component form of this red unit vector here. So we'll begin by determining the magnitude of vector A. So the magnitude of vector A would be equal to the square root of -1 squared plus 5 squared plus 2 squared, which would give us the square root of 1 plus 25 plus 4, or the square root of 30. The square root of 30 does not simplify, so now we can find the unit vector in the direction of vector A. The unit vector in the direction of vector A is going to be equal to vector A divided by the magnitude of vector A, which we just found. So this is the same as 1 divided by square root 30 times vector A in component form, which is -1, 5, 2. So the unit vector would have an x component of -1 divided by square root 30, a y component of 5 divided by square root 30, and a z component of 2 divided by square root 30. So while this is the unit vector in the direction of vector A, you may be expected to rationalize each of these denominators, so let's also show that. So if we have -1 divided by square root 30, to rationalize this we would multiply by square root 30 over square root 30, which would give us negative square root 30 over 30. And then to rationalize 5 divided by square root 30, we would multiply by, again, square root 30 over square root 30. But when we do this here, we have 5 square root 30 divided by 30. And notice how this does simplify again. There's a common factor of 5. So 1, 5, and 5, and 6 5s and 30. So this simplifies to square root 30 divided by 6. And then finally for 2 divided by square root 30, again we multiply by the square root of 30 over the square root of 30, which is equal to 2 square root 30 divided by 30. And again, this also simplifies. Common factor of 2. There's 1, 2, and 2, and 15 2s and 30. So if we do have to rationalize the denominators of each of these components, we could also express the unit vector with an x component of negative square root 30 over 30, the y component as square root 30 over 6, and the z component as square root 30 over 15. So it is important to recognize that these two unit vectors are the same, just the components are expressed in a slightly different form. And for the purpose of our homework, I'm okay with leaving it in this form here. But we should be aware of both forms. And again, this unit vector here is this red vector here, the unit vector in the same direction as this blue vector, the given vector A. I hope you found this helpful.